Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study the various addressing modes of 8051 microcontroller. So let us start with our topic. If we want to use the 8051 microcontroller for various applications, we have to write programs in the memory of 8051. Programs are nothing but they are the instructions which are written. Whatever operation the 8051 has to perform, that will be written in the form of instructions in the main program. Now every instruction which is written, it consists of two parts. One is the opcode and second is the operand. So each instruction in the microcontroller, it consists of two parts. One is called the opcode and second is called the operand. Okay. Opcode is just the operation specified by the instruction, that what type of operation is to be performed by the microcontroller. Okay, so opcode basically specify the operation to be performed, whereas the operand, it is the data on which the operation has to be performed. Suppose that if we are using the microcontroller for the addition operation, so the type of operation is the addition, and this addition has to be performed between two 8-bit numbers. So 8-bit numbers are the data on which the addition operation is to be performed. So 8-bit data becomes the operand and the operation addition becomes the opcode. So opcode is the operation to be performed, and operand is the data on which the operation is to be performed. So we can say that every instruction in the microcontroller, it has to operate on a data. It will have the data included in the instruction. Okay. Now the method of specifying the data, or we can say the operand in the instruction, is called the addressing, and the various modes of addressing are called the addressing modes of the microcontroller. So we can say that the definition for the addressing modes is that the method of specifying the operands in the instruction is called the addressing modes. So the method of specifying the data to be operated, that is the operand in the instruction, is called the addressing modes. Now this data on which the operation is to be performed, it can be anything. It can be like it can be a data 8-bit number or a 16-bit number can be there, or it can be a CPU register or a memory location or an input output port. So this data, it can be anything from these. the operand or data. It can be the data value itself, or it can be a CPU register, or it can be a memory location, or it can be an input output port. Okay, so data can be anything from these four things. Okay, now depending upon this data, there are various addressing modes in the 8051 microcontroller. Total, if we say, there are 8 addressing modes in 8051, and these addressing modes, they are categorized on the basis that how this data is specified in the instruction. So let us study these 8 addressing modes in detail of the 8051 microcontroller. If we write the name of these 8 addressing modes, first we have register addressing mode, register direct, indirect, immediate, relative, absolute, long and indexed addressing modes. So these are the 8 addressing modes available in the 8051 microcontroller. Let us study these 8 addressing modes in detail. First we will start with the register addressing mode. So in this register addressing mode, as the name says that it is the register, so data, that is the operand, it is found in the register itself. So data is in one of the 8 registers, that is from R0 to R7. These are the 8 registers. If we generalized it, then it is Rn, and n can be from 0 to 7. And these 8 registers, they are found in any one of the 4 register banks. In 8051 microcontroller, we have 4 register banks: bank 0, bank 1, bank 2 and bank 3. These are the 4 register banks. Each bank is having 8 registers in it. So this we have to first select the bank. Like if we want to use the register number 7 of bank 0, so first bank 0 is selected, and then we will write the R7 register in the instruction itself. So registers can be any out of the 8 registers, and bank can be any of these 4 register banks. Now how these banks are selected? They are selected by the bit number 3 and bit number 4 of the program status word. Program status word, that is PSW, it is the flag register of 8051. In this flag register, it is of 8 bits. And out of these 8 bits, we have bit number 3 and bit number 4, which is used for the selection of the banks. So these bits are RS0 and RS1. 2 bits are there. If these bits are 00, then bank 0 is selected. If it is 01, then bank 1 is selected. If it is 10, then bank 2, and if it is 11, then bank 3 is selected. So this is how the banks are selected, and once the bank is selected, we can write the register in the instruction itself. So that register contains the data for the operation. Okay. So that is why, because the operand, it is contained in the register, that is why this type of addressing mode is called register addressing mode. Now when the 8051 microcontroller, it is reset, okay, reset by making the reset pin as 1, so the default register bank becomes the bank 0. So whenever 8051 is reset, bank 0 becomes the default selected bank. So that registers of bank 0 will be selected at that time. Now if we talk about the general format of this type of addressing mode, that is register addressing mode, it will be, here we will have the opcode. Okay, opcode means whatever operation like addition, subtraction, multiplication, data transfer, or any type of operation. So opcode of that instruction will be there. Plus we will have the register here. So register can be any of the R0 to R7 registers. So this is the complete instruction. First is the opcode, and operand is there in the instruction itself. If we take an example here, ORL A, R3. So the operand, one of the operand is the accumulator, and second operand is the register 3. Suppose bank 1 is selected. So register 3 of bank 1 will contain the data, and that data plus the data which is there in the accumulator, they will be logically odd. OR is for the logical OR operation. Okay, so this is an example of the register addressing mode. Another example, if we take MOV R2, A. So this instruction, it is for moving the data transfer instruction it is. So the contents of the accumulator, they will be transferred into the R2 register of the bank which is selected. Okay, so these are the examples of the register addressing mode. Next addressing mode we have is the direct addressing mode. In direct addressing mode, the data, it is stored at some memory location, and that memory location is directly specified in the instruction itself. That is why it is called direct addressing mode, because we need not to specify the register in this case, or any indirect addressing is not there. Directly the address where the data is stored, that is given in the instruction. Okay. Now the instructions in which direct addressing is used, those instructions means because direct address is given. So this direct address can be of any on-chip variable or the special function registers. Okay, so any memory location can be there, or it can be any of these special function registers. Now as we know that in 8051 we have 256 bytes of the internal RAM, and out of these 256 bytes, 128 bytes are for the internal RAM, and 128 bytes are for the special function registers. That is from 00 to 7F we have the internal RAM, and from 80 to FF we have the SFR. So we have the direct addresses there. So in the instruction, if we are writing an address which is in between this range from 00 to 7F, so it will point towards a data memory. This is the data memory. And if the address is between 80 to FFH, so it is pointing towards the special function registers. Okay. So if we are specifying an address, because here in direct addressing mode we have to directly write the address in the instruction. So that address will be in this range from 00 to FF, means it will be an 8-bit address. So in this 8-bit address we have the bits from D7 to D0. Now when this D7 bit, if it is 0, like if it is from 00 to 7F, in this range the most significant bit is always 0. So if this D7 bit is 0, then it will be in the data memory space, and if this bit is in 1, then it will be in the special function registers space. Okay, so we can say that from the address also we can specify that which memory location is being called, okay, or it is this used. Now these special function registers, if we want to write the directly address in the instruction, instead of that we can write the mnemonics also for the SFRs. Like if we want to use the port 2, so for port 2 we have the mnemonic P2. So instead of writing the address for this port 2, we can directly write P2 in the instruction. Like for example, if we are writing here MOV P1, A. So the contents of the accumulator, they will be transferred or copied into the port 1. So instead of writing the direct address for port 1, which is 90H, we can directly write the mnemonic P1. So direct address where the data is stored, that is specified in the instruction. That is why it is called direct addressing mode. Similarly, if we have like MOV A, 07. So here the contents of the register number 7 of bank 0, they will be copied into the accumulator. So this address 07, it is assigned for the register number 7 of bank 0. So we are not writing that register here, we are directly writing the address here. So instead of writing the means, we can write the address also here, and we can write the mnemonic also here. So this type of addressing is called the direct addressing mode, in which the address of the data, that is the operand, it is directly specified in the instruction itself. Third type of addressing mode we have is the indirect addressing mode. In the indirect addressing mode, the address is not directly specified. It is indirectly specified. Means the address of the data that is stored in a register, and that register is specified in the instruction. Let's take an example here. So in this indirect addressing mode, the instructions which use this type of addressing, they perform an operation on the data whose address is contained in register R0 and R1. So the memory location where the data is stored, that memory location address is stored in register R0 and R1. Now in indirect addressing, we used this sign asterisk before R0 or R1. This denotes indirect addressing. So if we have to check that what type of addressing is used in the instruction, and in that instruction if we see this sign, then we can directly say that this instruction is using indirect addressing. So the data that is stored at the memory location. That memory location is contained in the R0 register, and that R0 register, that data will be subtracted along with the carry flag from the accumulator. Okay, because this instruction is for the subtraction instruction. SUB is for the subtraction and B is for the borrow. So subtract the contents of the address, okay, that is there in the R0 register. R0 register is having that memory location, and at that memory location data is stored. So that data along with the carry will be subtracted from the accumulator. So such type of addressing is called the indirect addressing. So whenever you see this sign in the instructions, you can directly say that this type of addressing is the indirect addressing. Next we have the immediate addressing mode. Now in immediate addressing mode, the data is directly specified in the instruction. So we can say that the operand on which the data is to be, on which the operation is to be operated, that is specified in the instruction itself. So there is no need to get the data from some register or from some memory location. The operand is itself the data. Okay, so this operand is given so when we store the instructions, we store it in the form of bytes. So we can say that operand, that is the data, this is the instruction. Instruction will consist of first the opcode and plus the operand. So 1 byte is there for the opcode and 1 byte is there for the operand. Okay, so operand is given as the byte that follows the opcode. Now this operand, it can be a numeric constant, means it can be a number, or it can be a symbolic variable, or it can be an arithmetic expression. Okay, so operand can be any of these. It can be a numeric number also, it can be a symbolic variable like any of the register symbols we can write, or it can be an arithmetic operation. Example of this is these are the instructions which uses the immediate addressing mode. So in this you can see that we are writing this symbol asterisk in front of all the numbers. So whenever you see this sign, it means that it is a type of immediate addressing. For indirect, we were having the as per at the rate symbol, and here for immediate we were having the asterisk signal. So this is the data, and this data is directly ANDed. This is for the AND operation. This is directly ANDed with the contents of the accumulator. Here this number 6C, it is moved or transferred, copied into the accumulator. Here this 16-bit number 0100, it will be loaded into the data pointer register. So here the data, that is the operand, it is directly specified in the instruction itself. It is the operand, means the second byte of the instruction, it is the operand itself. So that is the type of immediate addressing mode. Next addressing mode is the relative addressing mode. Now this type of addressing mode, it is sometimes also known as the program counter relative addressing. So this type of addressing, it is used only with certain jump instructions. Here in the instruction we will specify an offset address, and 8-bit address will be specified. That 8-bit address will be added up with the contents of the program counter, and that result, means the addition of program counter plus that 8-bit address, it will collectively give the physical address of the memory location. So that is why it is called relative, because it is related to the program counter. In program counter we are adding an offset value, and after that addition we are getting the address of the memory location where the data is stored. So this relative addressing mode, it is used only with certain jump instructions, and in this we have an offset address. This offset address will be an 8-bit address added with the program counter. And after addition we will obtain the physical address of the memory location. So because this type of addressing, it is used with the jump instruction, means the microcontroller, it has to jump to some memory location. So the address of that memory location will be obtained in this way. If we take an example here, suppose it is written that JC and then offset address is given. So now when this instruction is written in the main program, so microcontroller, it is going to jump at some memory location. So program control address of that memory location is obtained by adding the contents of the program counter plus the offset value which is there in the instruction. And also because this jump instruction, it is in conditional jump, means condition is specified, then only the microcontroller will jump. So condition is there that if carry is set, because here it is written JC, C is for the carry. So when the carry flag is set, then only it is going to jump at the memory location whose address is given by the contents of the program counter plus the offset value. Okay. So this type of addressing is called the relative addressing mode, in which the relative address, it is obtained with respect to the program counter. So contents of program counters are used in this addressing mode. Also remember that it is used only with the certain jump instructions only. Okay. Next type of addressing we have is the absolute addressing. This absolute addressing mode, it is used only with the two instructions. These instructions are the absolute call and absolute jump. This is absolute call and this is absolute jump. So only these two instructions, they use this type of addressing mode. In this addressing mode, because call and jump, both these instructions, they transfer the program control, means the microcontroller, it jumps to some memory location. So the memory location where the microcontroller is jumping, that memory location is located at the 2 kilobytes page of the program memory. So the microcontroller, it will be jumped to the memory location which is situated on the or located on the same page, that is 2K page of the program memory. How this is done? Because we have to know the address where the microcontroller has to jump. So that branch address, it is obtained by adding the 5 bits of program counter, then bit 5 to 7 of the opcode, plus the second byte of instruction. So when we add all these things, we will get the complete address where the microcontroller will jump when these two instructions are called. Or we can say that absolute address is obtained by adding these contents. Let's see. Suppose this is our program counter. Now program counter, it is a 16-bit register, so it will have the 16 bits here. Sixteen bits of program counter are there. Then we have the opcode. Opcode will be having 8 bits. 8 bits of opcode are there, and then we have the instruction second byte. First byte is the opcode and second byte is the operand. So second byte will also be of 8 bits. Now what in the absolute address we have to add? First we have to add the 5 bits of the program counter. Then we have to add the first 3 bits of the opcode, and then we have to add the 8 bits of the second byte. Okay, so branch address, it will be of 16 bits. So 16 bits are starting from this position. This will be the most significant bit: A15, A14, A13, A12 and A11. Then we have the 3 bits of this, so A10, A9 and A8. Then we have the 8 bits of this, so A7, A6, A5, A4 till A0. So these are the total what I have written with the red pen. These are the 16 bits of this branch address from A15 to A0. So this is how the absolute address is obtained. Now as I have told that this branching is done on the same page of the program memory. Same page, program counter, what it contains? It contains the address where the next instruction is written. So we are taking the 5 bits from the program counter. so that memory location is on the same page, because 5 bits are same in both the cases. Then we are using the bytes or the bits of the opcode and the instruction. So the branching is done, but it is done on the same page. Okay, that is why it is called the absolute addressing. So branch destination address is within the same page, 2K. Okay, so this was absolute addressing mode. Next we have the long addressing mode. This type of addressing mode is also used with only two instructions, L call address 16 and L jump address 16. So only these two instructions, they use this type of addressing mode, and in this addressing mode there are 3 bytes. The first byte is for the opcode L call or L jump. The second byte and the third byte, this is the 16-bit address. So it is the higher order address, and third byte is for the lower order address. So these type of instructions, they require 3 bytes, one for opcode and 2 bytes are for the 16-bit addresses. Now, as in the absolute addressing, we studied that the instructions, they jump or call the memory location which is located on the 2 kilobytes of the program memory. Whereas in the long addressing mode, the memory location, it can be anywhere in the 6 kilobytes of the program memory. So microcontroller, it can jump at any of the memory location which is there in this 64 kilobytes. So long addressing is used. The memory space available is very large. That is why it is called long addressing mode. Next we have the indexed addressing mode. Now in this addressing mode, the 16-bit address where the data is stored, that 16-bit address is obtained by adding the contents of the base register plus the accumulator. So here we have the two instructions, jump at A plus DPTR, and two move instructions, MOV C So for jump instruction, the base register is the accumulator, and for move instruction, the base register, it can be the data pointer also, means the offset, it can be contained in the data pointer also and in the program counter also. So we have in the accumulator, we have the positive offset, and that is added with the base register to get the complete 16-bit address. So suppose this in A accumulator, we are having the contents 08, and DPTR, it is having a 16-bit data. So that will be added, and the complete 16-bit address will be used, and that address will be there where the data is stored. So this type of addressing, it is called the index addressing, in which we are having a base register plus a positive offset which is there in the accumulator. You can see we have in these three instructions, we have the accumulator. In the accumulator, we have the content. Okay, so that content is added with either the DPTR, that is data pointer, or the PC, that is program counter. So these are the 8 addressing modes of the 8051 microcontroller, and these addressing modes is specified that how the operand or the data is specified in the instruction. So I hope that this topic is clear to you. Thank you.